Welcome to this HP Video Technical Configuration Guide. In this video, we're looking at link aggregation, specifically on HP COMware and provision switches. This is the second part of two parts discussing link aggregation between HP COMware and provision switches. In the first part, we looked at guidelines for implementation as well as command explanations. In this part, we're going to continue the discussion with a practical demonstration of link aggregation between two switches. So let's configure the switches. On the provision switch, show run. To view the configuration, notice that VLAN 10 is configured with an IP address and it's tagged across ports 3 and 4, which are the ports connecting the switch to the COMware switch. Show spanning tree. Notice port 4 is currently blocking in spanning tree. Only port 3 is forwarding. On the COMware switch, system view, display IP interface brief. This switch has got an IP address of 10.1.10.2. Provision 10.1.10.1. Interface gig 2025. Display this. Notice this is a trunk port permitting VLANs 1 and 10. The PVID or untagged VLAN is VLAN 1. Interface gig 2026. Same kind of configuration. Display SDP brief. Notice spanning tree is forwarding on both ports, and we can ping 10.1.10.1. Now let's set up link aggregation. On the provision switch, conft trunk port numbers, in this case 3 and 4. Specify the TRK group. Notice this switch gives you a lot of options. You're going to use TRK1. Specify the protocol, in this case LACP. What's important to note here is notice VLAN 10 is no longer tagging ports 3 and 4. VLAN 1 is untagged on TRK1. So it's important to tag VLAN 10 on the TRK. So tag TRK1. Show run. TRK is now tagged. Now the problem with doing this with the ports enabled is that it's affecting the network and spanning tree. So it would be better to shut the ports down before creating your trunks or bridge aggregation. Notice here how spanning tree is changing the states of ports. On the COMware device, interface, bridge aggregation. Pick a number. So 1 in this case. This doesn't have to be the same number on both sides. So TRK10 could connect to bridge aggregation 5. Specify link aggregation mode dynamic, which in this case means static LACP. Go on to the interfaces, so interface gigabit 2025, and assign the interface to the link aggregation group. So in this case, group 1. Do the same on the other interface. Notice please that interface VLAN 10 has gone down because this interface is part of the link aggregation, and if we go into the bridge aggregation interface, notice VLAN 10 is not permitted across this interface. So port, link type, trunk. Port, trunk, permit, VLAN 1 and 10. Notice the interfaces have been configured with the configuration done on the bridge aggregation. Interfaces inherit the configuration from the bridge aggregation interface. The bridge aggregation or bag has become active. So display this. or rather display this. Interface gig 2025, display this. Notice the physical interface is permitting the same VLANs as the bridge aggregation interface. So let's check the bridge aggregation. On provision, we can use the command show trunk. You can see ports 3 and 4 are added to TRK1 using LACP. To actually check the LACP, type show LACP. Notice LACP is active on ports 3 and 4. In trunk group TRK1, the port status is up and LACP status is success. You want to look for that keyword success. Show interface brief. In the output here, you can see that port 3 and 4 are added to TRK1 and the interfaces are up. To ensure that the VLANs are tagged properly, type the command show VLAN Port, and here we can specify our port, so TRK1. Notice VLAN 10 and VLAN 1 are configured on port TRK1. It's important to note once again that when you create a TRK, all VLANs that were previously tagged across the physical ports are removed. The TRK is untagged for VLAN 1, so you need to tag other VLANs across the TRK. On COMWare, display link aggregation summary. Notice the bag is configured, bag 1. The aggregation mode is dynamic, in other words we're using LACP. 2 ports are selected, none are unselected. So if you have unselected ports, it means you've got a problem. A more detailed command would be display link aggregation verbose. Here you can see that 2 ports, 25 and 26, are added to the link aggregation. The status is selected, and what you want to see here is ACDEF, which means that there's LACP activity, aggregation, synchronization, collecting, and distributing. So you want to ensure that you see ACDEF, which means that the bridge aggregation or link aggregation is working. Now, if ports are not selected or you have issues, check the speed and duplex of the ports. Ensure that the speed and duplex is the same on both sides and on all ports that form part of the bridge aggregation. Check the type of ports. If one side is configured as an access port and one side is a trunk port, you may have issues. Check the PVID or native VLANs. Check the untagged ports. Check the untagged and tagged VLANs across the port. In other words, the permitted VLANs. Essentially, to ensure that the bridge aggregation works, make sure that all ports are configured in the same way, so same speed, same duplex, same type, access trunk or hybrid, same PVID, same permitted VLANs. Let's look at spanning tree. So display SDP brief. Spanning tree is forwarding on the bridge aggregation port. On this side, show spanning tree. Notice ports 3 and 4 do not display in the output. So we have port 1, 2, and then 5. But notice here, please, the TRK is forwarding. So spanning tree is forwarding on all ports. Can we ping? So ping 10.1.10.1. Yes, we can. And on this side, ping 10.1.10.2. So in this example, I've successfully configured link aggregation or bridge aggregation or trunking if you prefer between a provision switch and a COMWare switch. If the configuration looks correct, but the link aggregation is still not working, shut the ports down and then undo shut them or enable them. If that doesn't work, remove the physical interfaces from the link aggregation, reset the configuration and put them back into the bridge aggregation. Now there are various load balancing options in link aggregation. The default is to load balance based on source and destination MAC address. COMWare has more options than provision, but for example, you could load balance based on source and destination IP address, or source IP address and source port number. By default, if a host on the left, let's say host A, was sending traffic to a host on the right, host B, that traffic would be sent across one of the links, not both. So even though you are link aggregating 2 gig interfaces, for example, the throughput is 1 gigabits per second, not 2 gigabits per second. The algorithms used by the switches are independent of one another, so it's possible that B's traffic uses the other port, but there is not a combined bandwidth of 2 gigabits per second for traffic from A to B. You'd have to change the algorithm from the default to, for instance, source IP address and source port number if you wanted to get greater throughput for an individual device. Statistically, however, with a bonded link, if many devices are sending traffic, the combined throughput in this example would be 2 gigabits per second. An individual session, however, wouldn't get the full 2 gigabits per second. This is shared amongst multiple sessions. That concludes this TCG discussing the configuration, setup, and testing of link aggregation between HP Provision and HP Comware switches.